Hi everyone, welcome back. Let's talk deeper on the topic of function headers. And now we've seen these before, but we're going to take a deeper dive in this video. And I want to illustrate a key concept in computing. This comes up over and over and over again through multiple courses, and you're going to see it a lot in your career. And it's an idea often referred to as abstraction. Well, what does abstraction mean? And it's fundamentally, in the context of computing, is to take something that's really complicated and hide these kind of ugly details, right? To make it easier to use something that's been already built, right? This happens all the time, and it makes it so that you can build very complicated systems without having to worry about every little thing that's happening in your computer system to get it to work. So let's look at it in the context of C programming and software related to functions. And I'm going to take a very simple function to kind of illustrate this point. Okay, in this point of separating the interface from implementation. Okay, separating the interface from implementation. Okay, so the interface, this is something that we want to be beautiful. We want it to be simple. We want it to be easy to know how to use it. Okay. And it could be hiding ugly implementation details that are complicated, that can have some sophisticated math or logic. In this case, the logic's very, very, very simple. It's just one line of code, but it could be a quite something really sophisticated. And what we want to do is we want to hide those ugly implementation details. The user doesn't need to know, okay, how something is being computed to be able to use some sort of functionality. Okay, so this get circle area is a simple one. We'll take a deeper look in a more complicated example momentarily here. Okay, but we have this function header. Okay, and the header, okay, here on the left is defining our interface. Okay, we got our inputs, we got the output, and we got the name of the function itself, okay? And then the body of the function is our implementation details, okay? And we're going to treat these separately. Okay? Now, going into this, let's look at the example of when we have our function, completed function here, and we have our main function as well, okay? And so far, we've been looking at functions and being defined where we define the function above the main, okay? We don't need to do that, okay? If I remove this right now, okay, if I remove this from above main and put it below main, though, it's going to give an error, right? Let me actually show you that, okay? So like right now, if I look at this example and we run it, okay, it's going to run fine. There's no problems. Okay, and just put in some sort of circle radius. Okay, and we get an output. No issues, no surprises. Okay. However, if I move this below main, okay, this is going to cause a problem. Okay, so all I did is I cut the function from above main and put it below. And I'm going to try running this again. Okay. And notice we got a compile time error. Let's take a look at the error. Okay. And we're getting something that's saying implicit declaration of function get circle area. We're getting, there's multiple errors related to the function here. We're seeing it come up on line 13 where we're calling it, and we're also seeing it down here below on line 18. Okay. Now, what's going on in this case? The compiler works by compiling from the top down. Okay, so the compiler is going to look at your file, your source code file here, and it works from going top down. Okay, and when we had the function above main, okay, the function was defined prior to the compiler ever seeing it being called. Okay, prior to the function being called. So we had no problem, all right? It was defined so that when the compiler hit this and tried to compile this line, it said, oh, I already know what that is. I already know what get circle is. or get circle area is. I already understand what that function is. Okay. Now, when we moved get circle area below main, okay, we hit this line where it was called before it knew what the function was. So what we can do in that case, all we need to do to get this to work is we need to tell the compiler, okay, we need to tell the compiler what the function header is. Okay. If I do that, if I put the function header above, it needs to be defined before it's ever being called. Okay. Now when I compile this, it's going to work fine. Okay. Built successfully. Okay. And that's because we think from the top down, right? The compiler comes down, it hits this line here, and it says, okay, a function's going to be defined, right? And it's going to have these inputs, this output, and it's going to be called this, get circle area. Then when the compiler hits this down here, okay, line 15, it says, okay, right? I don't know how that function's implemented yet, but I know it exists, right? We've defined the inputs, outputs, and the name. This is valid use of it, okay? And when we get down below, and if I sometimes the IDE doesn't let me run it so that it gets rid of that error, right? That was kind of a lingering problem from the previous run. That when we get down here, right, it's now actually has to be defined. So it's important that we can't just leave the interface and not define it, right? Then we don't have the logic to actually run it. Okay, that would cause a problem too. But this is how we can define a function below the main function. Okay, so this idea of having the interface of a function defined is going to come up again and again. Okay, and this is, right now we're going to see it in the context of using just one single file. Later on, we'll look at breaking up in the real world, right? Programs can get really large. You can have lots of different files, and we're going to look at how this is going to help us being able to split up our programs into multiple files, all right? But that'll be a topic for another video. All right, so this idea, okay, of having the function prototype is a really important one, okay? In addition, I want to point out one other thing, right, is that it's more than just to have a really well-defined interface. Documentation is really important, okay? So a common way of documenting functions is to do the following, right? Where you have a little bit of a description of what the function does, defining what the inputs mean and what the output is, okay? This is a really good way of commenting your function, right? The idea is that oftentimes other people are using your functions, or you're coming back and using your own that you wrote a while back, and this is a good way of keeping things organized, okay? Now, also, right, this is the same idea that when you use libraries, right, you're using functions that are defined in libraries, code written by other people, right? And you need to know how effectively, notice that these comments aren't defining how it's implemented, what the logic is internally in the function. It's telling you what the function does and how to use it. Okay, that's what you care about for someone using the function. Okay, it's the same idea, right? If we did a more complicated function, this is the choose function, right? This is the one that if you should have seen somewhere else, math in high school or something, where you're looking at how many unique subsets there are in a given set. So like, for instance, if you're trying to say like how many teams of 3 can you have if you have 20 students in a class or something. So it takes 2 inputs, N and R, right? Say 20 students, teams of 3, right? And tells you how many, and it returns how many unique subsets, right? How many unique teams you could, in that case, you could form. Right? Now the interface, right? We just need to know that we have N and R coming in, right? And it's going to return, everything's an integer. It's going to return an integer, a number of subsets, right? And then we've got the ugly implementation details, which is actually, in this case, is more than just the formula. It's got the formula defined up here too, but you could also have invalid inputs being entered that could cause issues. Like, for instance, R should never be greater than N. If it is, right, that's a problem, and they should both be greater than or equal to 0 as well. So we've got some kind of error checking code going on here in the function, so some implementation details about that. And then using the formula, right? And notice that functions can call other functions. In this case, we're assuming that a factorial function has already been built, right? And we're using it repeatedly, right? We're actually calling it 3 different places, okay? Implementation details, okay? Now, to keep the interface as clean, organized, and simple as possible, you don't want to pass in any information that you don't absolutely need to pass in. Okay, you don't want to pass in any information that you don't absolutely need to pass in. So if we come back to this example here, notice that we didn't pass in pi, right? We didn't pass in pi because it's a mathematical constant. It doesn't change, right? It should never change, right? It's so what we did, and this is something that's a bit new, I'd imagine is new to you, is we actually, there's multiple ways to do this, but in this case, how we used it is, now you could imagine you could have just put the value of pi and you could have just written it right here, right? And that would work, okay? Another thing you could do is define what we call as a global variable, okay? And the scope of that variable is from where it's defined through the entire file, okay? So in this case, the scope cuts across the entire file because it's global. It's outside of a function. Notice it's not in any code block, okay? In that case, that will work, right? Now, you want to be very careful using global variables, right? If it's something like a constant value or whatever, it keeps the code organized. There's really nothing wrong with doing that. You don't want to start putting a ton of stuff as global. It makes the code very disorganized and likely to break things, okay? But notice the key idea here, right, is we are not passing pi in as an input, okay? Because they don't need to. All that does is complicate the interface. We want to keep the interface, right? We want to keep the interface as beautiful and as simple as possible. Okay, hide those details. We don't need to pass in pi. It's not going to ever change. Okay. All right, same idea here. Pass in the bare minimum information you need to compute what the function's supposed to do.